All right, so today we're going to be looking at 3.4, and we are going to look at the three type of functions that we're going to focus on moving forward this year. We are going to be looking at linear functions, which should be very familiar from pre-algebra. But then we're also going to be talking about this other two types of functions, quadratic and exponential. So a linear function is going to follow that y equals m. Let's make that nicer. Y equals mx plus b form that, again, hopefully you are very familiar with from pre-algebra. When the m in our equation is positive, so let's just write an example. If we have something like y equals 2x plus 5. This is our m value because it's right in front of the x and it's positive. So this line, when we draw it, is going to be an increasing line. So that line is going to go up from left to right. So again, whenever m is positive, we're going to have a line that's increasing. But the opposite is true for if when our m is negative. So when our m is negative, and for example, we could use like y equals negative 2x plus 5. Well, now our m value, that number that's right in front of x, that's our m, that's negative. So that is going to cause our line to be going down as we look at it from left to right. And if we have a line that's going down from left to right, then that function is going to be decreasing. So not only are we identifying here these linear functions, but we're identifying, are they increasing or are they decreasing? Okay. Our quadratic functions are in this form. Y is equal to, this is going to be the standard form, ax squared plus bx plus c. So now we're going to talk about what this graph looks like. And again, it's going to look different. Just like with our linear, this leading coefficient, this first coefficient, if it was positive, it was increasing. If it was negative, it was decreasing. Well, this leading coefficient, the a value, if the a is positive, so let's write an example. If we had something like y equals 2x squared plus 5x plus 1. Just an example. So this a, this leading coefficient of x squared is positive, which means when this is graphed, this is going to make a U-shaped graph that opens up. So once again, if a is positive, we have a U-shaped graph that opens up. So these quadratics, these U-shaped graphs that we saw in the last couple sections, these are created by these quadratic functions. And then the opposite, just like with linear, is true if a is negative. So if I had something like y equals negative 2x squared plus 3x minus 1, I don't know, plus 1. It doesn't matter what the function is right now. All that really matters is that you can tell me, you can look at this function, see that this leading coefficient of the x squared is negative, and what that's going to mean is we're going to have this U-shaped graph now that opens down. So if a is negative, this U-shaped graph is going to open down. So a quadratic function will be x squared. It's probably important that we pick that out. If it's quadratic, it's going to have an x squared. And if a is positive, it's going to be a u that opens up. And if a is negative, it's going to be a u that opens down. Exponential functions. The standard form of an exponential function is y is equal to a times b to the x power. So what you'll notice with exponential functions is that our x value is an exponent, hence why it's an exponential function, because x is the exponent. And when this b value is greater than 1, so let's say we had something like y equals 1 times 2 to the x power. If this b value is greater than 1, which 2 is, then our graph is going to be increasing. And it's going to be like an increasing slide. I don't love that one, but it's going to look something like that. So I say it looks like a slide, but as we look at it from left to right, that graph is going up. And since it's increasing, it is going to be an example of a growth function. So it's exponential, but it's an exponential growth because it's increasing. And then on the opposite side, if our b is less than 1, so let's say our function is y is equal to 1 times 1/2 to the x power. So now 1/2 is less than 1. And what this is going to cause our slide to do is instead of our slide increasing, our slide is going to be decreasing. And when your slide is decreasing, it is a decay. So if something is decaying, it's decreasing. So 3 types of functions. We've got our linear functions, which is basically just m or x to the first power. And those will be in y equals mx plus b form. And if m is positive, the line's going up, which means it's increasing. If m is negative, the line's going down, which means it's decreasing. A quadratic function is going to have an exponent of 2. So if the equation has an exponent of 2, it is quadratic. Then, to know if it's opening up or opening down, you're looking at that a value. If the a is positive, the graph is opening up. If the a is negative, the graph is opening down. And then last one is going to be exponential, and you will know an equation is exponential if x is the exponent. If x is the exponent, it's exponential. Then you will look at this b value. If this b value is greater than 1, it's going to be a growth because it's increasing. If this value that's being raised to this x power is less than 1, like 1/2, then that's going to be a decay because that's decreasing. All right, so now what we're going to do is we're going to look at a bunch of mixed examples, and we're going to classify them as linear, quadratic, or exponential. And then if they're linear, we're going to say, is it increasing or decreasing? If it's quadratic, we're going to put whether it opens up or down. And if it's exponential, we're going to then classify it as a growth or decay. So number 1, our first example is this U-shaped graph. The type of functions that make this U-shaped graph are going to be this function in the middle. So this is going to be an example of a quadratic. And since it's a graph, it's pretty easy to tell that it opens down. So that graph is a quadratic that is opening down. Number 2, we have an equation. Y is equal to 1 times 5 to the x power. So this x is in the exponent, and since the x is in the exponent, that means exponential. Then remember, if it's exponential, we're determining if it is a growth or decay. So the b value, because remember this is y equals a times b to the x, that b value is 5, which is greater than 1. So that means that this is going to be a growth. Number 3, we are back to a graph. So hopefully it's very easy to tell that this graph is making a line. So that is going to be a linear function. And then we look at graphs just like we read books. So we are looking at this line from left to right. And as I trace it from left to right, it's going down, which means it is decreasing. Number 4, we have another equation, y equals 2x squared plus 9x minus 1. So this equation has an exponent of 2. Anytime there is an exponent of 2, we need to know that that means quadratic. So since this is x squared, this is going to be a quadratic function. And then, since it's quadratic, we have to determine, is it opening up or is it opening down? So we're looking at this leading coefficient. This leading coefficient is a positive 2. Since the leading coefficient is a positive 2, that graph is going to open up. So I'm finding that right here. A is positive, this leading coefficient is positive, so this graph is opening up. So this is going to be a U-shaped quadratic graph that opens up. All right, number 5, we have y equals 4x minus 1. This equation is in y equals mx plus b. There is no exponent, right? That just means x to the first power. So this is going to be linear. And then in this equation form, to determine if our line is going up or going down, looking right here, it's in y equals mx plus b, and if m is positive, which ours is, then this line is going to be increasing. And last but not least, we're looking at a graph. So this graph is making what I call a slide. Whoop. So these graphs that look like slides are these exponential functions, this third type of function. So this is going to be exponential. And as I look at that slide from left to right, that slide is decreasing. So this would be a decay. So it's an exponential function that's decreasing, therefore it's going to be an exponential decay. And again, that's right up here for you if you need that reference. Okay? All right, so that's equations and graphs of those 3 types of functions. Now we're going to look at tables. So how can we identify linear, quadratic, or exponential from a table? So if we are looking at linear tables, there's going to be a common difference in the y values, meaning they're going to be adding by something or subtracting by something. So, okay, so if we look at this first table, if we are looking at the y values, these y values are going from 1 to 4, 4 to 7, 7 to 10. So what's happening as the x values increase, we're going plus 3, plus 3, plus 3. So since we have that common difference of plus 3, this table would be a linear table. And because it's going up, we know that this line would be increasing. So since that rate of change in those y values is going up, this would be an increasing line. Where if we look at the second example I've given you, we go from 10 to 5, 5 to 0, 0 to -5, -5 to -10. So what's happening with the y values there is we're going down by 5. 10 minus 5 is 5, minus 5 is 0, minus 5 is -5, minus another 5 is -10. So we see that constant rate of change of -5, and since it's negative, that's how we know that that line is going to be decreasing. Okay, so if there is a common difference, if it's a positive difference, then it's going to be increasing. If it's a negative difference, then it's going to be decreasing. Then we're going to move on to quadratic, and what you will see with the quadratic y values is that they are going to be mirror images. So the y values will be mirror images of each other. So if I look at the first example that I gave you, the y values go from 6 to 3 and 3 to 0. So down 3, down 3. But then we go back up to 3 and back up to 6. So then it's plus 3, plus 3. These y values are mirror images of each other. 6, 3, 0, and then back up 3, 6. So because of this mirror image, that's how we know that that this table is going to be quadratic. Now, what we need to decide is this quadratic going to be opening up or down? Well, it's easy to tell because these differences are going down and then back up. So if something is going down and then back up, well, that means that that graph is going to be opening up. And once again, I knew that because it goes down and then up, because it's negative, negative, and then plus, plus. So down and then up means that that quadratic is going to open up. Then if I look back here, or in the second example, we have -3 to 0, 0 to 1, but then back down to 0 and back down to -3. So from -3 to 0, we went up 3 and then up 1. But then from 1 to 0, we went down 1. And then from 0 to -3, we went down 3. So this time, we were going up, up, and then down, down. So if we go up, up, and then down, down, up, up, down, down, well, that's the shape of graph that we have. Therefore, we know that that quadratic is going to open down. And you can easily see those mirror image points, -3, 0, 1, and then 0, -3. So these zeros are on each side of the 1, and the -3s are on the outside. So you have those mirror image points. That's how we know it's quadratic. Mirror image points, quadratic. Then you just need to look at what's the pattern. Is it going down, down, up, up, or is it going up, up, down, down? And last but not least, our exponential functions. Here, what you're going to see is there's going to be a common ratio or a multiplier in the y values. So the y values are going to be getting either bigger or smaller very fast. So they're going to be multiplied by the same thing over and over. Keep in mind, linear over here, this is adding and subtracting. Exponential is if we see multiplication. So if we look in our first table, we have 1 to 3, 3 to 9, 9 to 27. Well, times 3. 3 times 3 is 9. 9 times 3 is 27. So we see that common multiplication. And since we are multiplying by 3, which is a value that's greater than 1, this table is not only exponential, but this is going to be a growth because it's getting 3 times as big each number. Our second table is going to show us the opposite of that. So we go from 90 to 30, 30 to 10, 10 to 3.3 repeating, which that can be kind of tough. But if we just look at the first 3, well, 90 divided by 3 is 30. 30 divided by 3 is 10. So this does look like it's dividing by 3, but remember when we divide by something, it's the same thing as multiplying by the reciprocal. So dividing by 3 is the same thing as multiplying by 1 over 3. So these values are getting smaller because we're multiplying by that fraction of 1/3. And then hopefully logically, kind of what makes sense is that if we see these y values getting smaller, we know that this exponential table is going to be a decay. So since those y values are going down, they're decreasing, that's going to be a decay, and they are being divided by 3 or multiplied by 1/3. All right, so linear, we're looking for a common difference. Quadratic, we're looking for those mirror image. And exponential, we're looking for, are those y values being multiplied by something? So same directions on these next 6, which I know it's a lot of examples, but I want you guys to just have an example of every single type so that you can go back and reference these if you have questions. So let's look at the first one. Let's look at what's happening with these y values. 8 to 9, 9, 10, 10 to 11, 11 to 12. 8, 9, 10, 11, 12. Hopefully that's pretty easy to see that we're just doing +1, +1, +1. So since we have that common difference of +1, this is linear. And since we're adding 1, since those y values are increasing, this is going to be a line that is increasing. All right, number 8, looking at these y values on this table. 48 to 24, 24 to 12, 12 to 6, 6 to 3. So those y values are going down. Hopefully that's easy to see. And they're not going down by a common number, but instead, hopefully you see that they're being halved, right? Half of 48 is 24. Half of 24 is 12. Half of 12 is 6. Half of 6 is 3. So they're being divided by 2, or like we said, those are all being multiplied by 1/2. That's how we're getting from one value to the next. We're splitting it in half. So since we have this multiplier, this table is going to be exponential. And then since the table is going down, we know that decreasing means that that's going to be an exponential decay. So it's an exponential table that's going down, so it's going to be decay. It's decreasing. Number 9. 6 to 0 to -2. And then look at this. We're back to 0 and then back to 6. So we have this number in the middle and then 2 zeros on the outside and then 2 6s on the outermost of this table that we're given. So we see these mirror image points in the y values, which tells us that it's going to be quadratic. And then with the quadratic, we need to determine, is it opening up or down? So let's look back at this pattern. From 6 to 0, that's down 6. From 0 to -2, that's down 2. From -2 to 0, now we go back up and back up. So we're going down first, which this would be decreasing, and then up second. So if we're going down first and then up second, that means that that quadratic is going to open up. So the way that I draw that visual every time, you guys need to be doing that. That will help you. If you actually take your pencil and you say, I'm going down, and now I'm going back up. And now I just have to look at the picture that I drew. It's opening up. All right. 3 more here on these tables. We have 3/4 to 3/2, so the fractions might be a little tricky. But then we're going up 3, 6, 12. And these fractions kind of help give it away too because we're getting bigger much quicker. And if we're looking at just the 3, 6, 12, hopefully you know that 3 times 2 is 6, and then 6 times 2 is 12. So this table, these y values are being multiplied by 12, and when we have that common multiplier, that's when we know that it's going to be exponential. And then because these y values are going up, it's increasing, which means a growth. It's increasing, which means a growth. Two more. Number 11. We've got 0 to 12, 12 to 16, and then look at this. We're back to 12 and back to 0. So we see those mirror image in the y values, which tells us quadratic. Then we need to determine opening up or opening down. So if we're going 0 to 12, that's going up. 12 to 16, that's going up. Then we go back down and back down. So if I were drawing this, I have to go up and then down. So if I go up first and then down, well, now I can easily see on my picture that that U-shaped graph is going to open down. Then our last table here, our y values are 5 to 3, 3 to 1, 1 to -1, and -1 to 3. So we don't see a mirror image. It's not being multiplied. 5 to 3 is -2. -2 again, I get 1, -2, -2. So those y values are going down, and they're going down by a minus, by a common difference versus a common multiplier. So since they're going down by a common difference, that's how we know that it's going to be linear. And it's going down, so it's going to be decreasing. So if those y values are increasing or decreasing, you know it's either going to be linear or exponential. You just have to determine, is there a common difference or a common ratio? And then if those y values are those mirror image points, then you know it's going to be quadratic, and you just have to determine, is it going up or down? All right, the last thing we are going to look at today is from situations. How can we identify if it is linear or quadratic or exponential? So with linear functions, these situations are going to have an additive property. And you need to look for words that would mean like a slope or a constant rate of change, because that's how a linear function is. So those words might be words like each, or every, or per. Those are words that would represent a constant rate of change. Each, every, per, additive words. So here's the example that I've given you. Raphael has 25 seashells and collects 5 more every beach trip. 5 more every beach trip. So this is going to be linear because she's going to have 5. And then after she goes to the beach trip again, now she's got 30. Then she'll have 35, then 40. So she's adding 5 every time she goes to the beach. And that's what's going to make it a line. Okay? With our quadratics, these U-shaped graph, these situations, maybe we'll even draw that. Linear, line, quadratic, U. So these situations are usually involve something being projected in the air, meaning they're going to describe an object that goes up and then down. So maybe we should have made our U-shaped graph something like this. Something that's being projected. It goes up and then down. Or it could be problems with area, because we know area is squared and quadratic are our squared functions. So the example that I gave you here is a soccer ball is kicked into the air from the ground. So that soccer ball is going up and then going down. And then we have that U-shaped graph. And last but not least, we have our exponential functions, and that's where that x is going to be the exponent. And these situations are going to involve a multiplicative property because it's being multiplied by something. And in these kind of problems, you want to look for percents of increase or decrease, as well as multiplier words like double, something is doubling, or you could have something tripling. Or you could even have like something like a half-life. Because if something has a half-life, that would mean like we're multiplying it by 1/2. Just like doubling it would be multiplying it by 2. Tripling it would be multiplying it by 3. So if you have these word problems that have percents of increase or decrease, or they use those multiplier words, then we're going to have that exponential function. So an example here is the population of a certain town is expected to double. Because it is doubling, that's how we know that it's going to be an exponential function. All right. Last 3 examples here. The directions are the same as they were for the last 2, where we're going to classify the function as linear, quadratic, or exponential, and then determine increasing, decreasing, opens up or down, growth, decay, whatever, just more specific about what that graph's going to look like. So number 13, a diver jumps from a diving board that is 10 feet high with an initial upward velocity of 4 feet per second. So what you need to recognize is that we have something jumping from a diving board to a certain height. And yeah, they gave us the speed, but that's okay. If you think about what that would look like, if I have a diving board, here's my water, here's my diving board. If that person jumps off the diving board, that's 10 feet high, they're going to jump up and then they're going to go back down. So essentially what kind of graph they're making is this U-shaped graph that opens down because they're going up and then they're going back down. So that is what's going to help us identify that it's quadratic and that it opens down. Number 14, Garrett buys a bag of dog food. He feeds his dogs 2 cups of dog food per day. So we start off with a certain amount of food, and then every single day it's going down by 2 cups. So that's a constant rate of change, which is how we identify that it's linear. And if the amount of food he had is going down by 2 cups every single day, then that line is going to be decreasing. You start with a certain amount of food, and then each day you take away 2 cups. And the last one, number 15, Juan just got hired at his dream job. They are offering an annual salary of $65,000 with a 3% increase in salary every year. So this percent increase is what's going to help you determine the type of function that this is, which is exponential. And again, just logically, if it is increasing, if he's going to make more money every year, then this would be an exponential growth example. All right. So I know that that is a lot, but there are a lot of examples here for you to go back and look through. So please use these notes as a reference when getting that practice assignment done.